All right, this is section 6.2 in the calculus book, and I wanted to just run up through a few more problems from the homework. For instance, number 1, if you have dy dx is equal to x plus 2, what you do is you're going to try to separate your variables, get all of the x's on one side, the y's on another, and then you can integrate both sides. That's the big idea. All right, so what we can try here is to cross multiply. I get x plus 2 times dx on one side, and on the other side I get dy. Now, after I've cross multiplied, I check, do I have all the x's on one side and all the y's on another? Well, I do here. So what I'm going to do now is I'm going to integrate both sides. So I'm going to make it a different color just so you see that it's another step. I'm going to integrate both sides. And when I do, I'm going to get, let's see, the integral of x dx would be x squared over 2, and then I'd have 2x. And I'm going to have a c, so I'll just stick it on this side. And the integral of dy is just y. So what I end up with is, if I just write this where it looks more like what we're used to seeing, y is a half x squared plus 2x plus c, and that would be separating the variables also would give me, this is basically solved for an equation. Instead of being a derivative, I've been able to get the equation. So you're basically being given a derivative and you're writing the equation from it when you have two variables. Sometimes you might have to do something like, well, let's just look at more problems. We'll talk about that as well. Okay, looking at number 15, that would be a good one to maybe go over. dy dx, and they may just give you y prime, and you might have to change it into dy dx, but here, at least I have it written down this way on my paper from where I did it, is 6 times x minus y. Oops, that's not right. Let's see if I can undo some of that. 6 minus y times 1. And they want us to evaluate it at the point 0, 0, I guess, once we get done. Okay. So what we're going to do go ahead and cross multiply. Dy times 1 is dy. And then I have x, if I multiply this way, 6 minus y, 2x. Okay. Now I haven't got all the y's on one side. Let me do this. Let me come in and let me divide that term that has the y in it out of both sides. I'm going to divide both sides by 6 minus y. So I'm going to write it like this in the next step. 1 over 6 minus y dy equal x, let's see, oh, I wrote down 2x instead of dx here. This should have been a dx. I don't know what I was thinking. So that would be x times dx. That's all I'd have left there. Now, if you think about it, when I integrate this, I'm going to end up with kind of a bit of a mess over on this side. On the left-hand side, it's going to be a ln. So let me get rid of the negative on the y just by factoring it out. I'm going to say that's 1 over y minus 6 dy, and I'll put a negative 1 here, but just because it's still going to be easier to deal with it when it's on the other side. Now I'm still going to multiply both sides by negative 1. I'll come up here to write what I'd have. I'd have 1 over y minus 6 dy, and then it'd be negative x dx. Now that's easier to take care of on the left-hand side. I don't have to have it messing with me inside my natural log, because there's just all kinds of things that end up happening with negatives. So what I'm going to do now is I'm going to integrate both sides, so I'll draw that in a different color. Now what I have on the left-hand side is ln y minus 6. And if I'm taking the derivative of y with respect to y, the derivative of y would be 1, so I don't have anything else on that side but ln y minus 6. But on the other side, I'm going to have negative x squared over 2 plus c. I'll put the plus c there. I'm going to squeeze it in down here. Okay, now I don't want to leave it like that because it's really not solved for y yet, and there's some other stuff I'm supposed to do with it in the problem. So here's what I'm going to do. I'm going to take and I'm going to use e, and I'm going to make each side an equal exponent on e. Okay. Now, when I do that, that's going to get rid of the e and the ln. Remember, they kind of cross each other out. So this is going to be absolute value of y minus 6. And then I'm going to get e to the minus x squared plus c, except that when you add exponents, if you remember the log rules, we can take that constant term down and put it out front. So that's what we're going to do. E to the minus x squared over 2. And we really don't have to worry about the absolute value on the y anymore because we kind of got rid of the log. So we're just going to put y minus 6 equals ce raised to the negative x squared over 2 power. Okay, so here's what we've got here. Y minus 6 equal e to the minus x squared over 2 plus c. No, we put the c out front already. Sorry, I was trying to remember what I did on the other page. So let's just add 6 to each side. And this kind of gets it solved down for y, okay? So y equals ce. Maybe let me put the 6 out front just because it'll make it easier to look at. Now, what I'm trying to find here is the exact equation. So they're giving me a point on the equation. That point was 0, 0. I'm just going to write it up here in green. So what I'm going to do now is plug that in. Now, here's something you may remember from what we talked about in class. The initial value is always, this is basically an exponential equation, and the initial value is always what is your y value when x is 0. So I could plug it in. I could plug in y equals 0 and x equals 0, but what I end up with is, well, let me just go ahead and plug it in instead of, we'll just show it once plugging it in. All right, so I'm trying to find out what c is. I should have plugged x equals 0 in, not, that's what I'm going to do now. So it's x is 0. Actually, this was supposed to be 0 over here, so I'll plug it in. I'm plugging in that point now. Minus 0 squared over 2. All right, so I have 0 equals 6 plus c. Now, negative 0 squared over 2 is 0. E to the 0, I don't know if you remember this, but it's equal to 1. Anything to the 0 power is equal to 1. So I have now 0 equals 6 plus c. So what is c? If I'm trying to figure out what it is negative 6. Normally, if I just had the exponential equation and I didn't have the y minus 6, or if I, you know how I've got this 6 over here on this side, the reason I couldn't just take the 0 and say, well, at x equals 0, the initial value is y equals 0. The reason I couldn't just plug it in here is I really needed to know what c is, and I could have done it, could have plugged the 0 in for c, if I hadn't had all the 6 added or subtracted from it. It's not just a straight proportional kind of thing. It's the exponential equation, but it's been shifted basically up 6. So that kind of throws my values off. I gotta kind of compensate for that. So I actually had to plug it in here just because I had something added or subtracted to the exponential equation to figure out what c is. Now, I haven't written the answer yet, because the answer is y equal, I'm going to go back right to here. I found out what c is. C is minus 6, so it's going to be like plus negative 6, which is minus 6. C, and then e to the negative x squared over 2. And, you know, what's going on here, if you look at a graph, it's doing something like this. You know, you might have something like that going on. Okay, so the problem number 11 says the rate of change of q with respect to t, that would be the dq dt, rate of change of q with t, is inversely proportional. Inversely proportional means that the variable is going to go on the bottom, and it's to the square of t, so you have t squared on the bottom. And if you remember anything about direct variation, proportional equations, or inverse variation, inversely proportional equations, you have a constant of proportionality. That's what this k is here. In this problem, they don't give us a point to plug in, so we can't figure out what k is. But we can write the general equation of it. Okay, I had forgotten to turn on the the recorder, so that's why everything's already written here. I realized it when I was in the process of cross multiplying that it wasn't on. So that if I cross multiply, I get k dt on one direction, and on the other direction I'm going to get t squared dq. Okay, now what I really want to do is get all the t's on one side and all the q's on the other. So let's see, the q's here, I got t's over here, I've got dt over here, so let me move this t squared to be with dt. So it's dt's in the right spot. So I'm going to divide by t squared. And so this is going to give me, go back to writing in black now, k over t squared dt, remember k is just a constant, is equal to dq on the other side. So k is just a number. We don't know what it is. We're not going to worry too much about it. But what we do next, if you remember, after we get our variables separated and one on one side and all the rest on the other side, we integrate both sides. So what I'm going to get, I'm going to rewrite, I'm going to go to the top here to work now. I'm going to rewrite k over t squared to k times t to the minus 2 power dt. And that way, it's easier for me to think about how to integrate it. Okay, I can pull the k out front, and what I do with the t is I say you add 1 to the exponent, so negative 2 plus 1 would be negative 1, and then you divide by that new exponent, negative 1, and then there's the constant. Get that off of there. There's a constant here of integration. On the other side, the integral of dq would just give me q. So if you look, I've got my equation. I'll write my q on the left-hand side. That k divided by negative 1 is just a negative k. T to the negative 1 power just moves the t back to the denominator. So I have negative k over t plus c. And that's how you do 11.